Homework 1.6, other types of equations, video 3. Homework's due on Saturday, May 16th, 2020 at 11:59 p.m. In the previous two videos, we looked at polynomial equations, which were basically just bigger solved by factoring problems. For the next two videos, we're going to look at square root equations. And you might be thinking, we've already done this. We've seen equations, we use square roots, so why are we doing it again? The difference between these and those is that previously we had equations that had squares in them and then we brought in a square root to get rid of it. And these equations, it's the reverse. We're starting an equation that has a square root. Gee, guess what we're going to do to both sides to get rid of it? Let's take a look at this example. Solve the square root of 18 minus 3x is equal to x. You may notice in some of these problems on the square roots, I'll drop a little tail. That's to emphasize that that is the end of the square root's radicand. Radicand, R-A-D-I-C-A-N-D, is the name of something under a square root symbol, or a cube root, or any other root. So how do we solve this? Well, general equation solving protocol is to get the x by itself. And this one already is, but this one's not. It's trapped under the square root. So we got to get it out of there. And as you may already know, to get rid of a square root, you can square both sides. I've already set up a template over here to document the steps that we're going to do. But the first step we're going to do is actually number 2 over here. Square both sides. Why is it not the first step? Well, in the next problem, you'll see what the first step is. It's just not necessary on this particular example. So let's square both sides. 18 minus 3x is going to get squared, and the x is going to get squared. Now, as a consequence of that, the square and the square root cancel. So square and square root cancel. We get 18 minus 3x. And on this side, we just have x squared. It is no longer a square root equation, but now it's quadratic. Your third step is to finish solving. Now be careful. When you get to this step, you're going to have to shift gears. I was solving a square root equation. Now I have a quadratic equation. So how can I solve it? Well, regardless of how you choose to solve it, you're probably going to get it equal to 0. So if I want to get this equal to 0, I have a decision to make. Do I want to move the x squared to the left, or do I want to move everything else to the right? Well, I think this is the third chance I've gotten to say this. When you're moving things around in anticipation of solving an equation, and specifically factoring, which I'm going to do, you really want your highest power to end up positive after all the moving is done. Since the x squared is already positive, I'm going to leave it on the right side and bring everything over here with it and zero out the left side. So there's the x squared. If we bring the x term over, it will change signs and become a plus 3x. And if we bring the 18 over, it will change signs and become a negative 18. I don't know if you can hear my stomach growling, but my stomach's growling. Okay, could you get out the quadratic formula? Of course you could. But I will tell you in this section, if you get to any quadratic equation, it should factor. Unless there's just one x term, in which case you can just solve for x. But this guy will factor. And you're welcome to use the quadratic formula, don't get me wrong. But you'll take a lot longer to solve some of these things than necessary. What two numbers add to give 3 and multiply to give negative 18? Well, if they add to give 3, the bigger number has to be positive. And if they multiply to give a negative 18, the other number has to be negative. I think 6 and 3 get the job done. 6 plus negative 3 is 3. 6 times negative 3 is negative 18. So set each factor equal to 0 and solve, and we get x equals negative 6 and x equals 3. And it seems like everything's over. It says x equals. However, if this were a homework question, and I believe this were my homework number 5, question number 5, then you put in both answers, it's going to go, wrong, and then it'll give you some feedback, some insight on why it would be wrong. Now don't get me wrong, we didn't do anything incorrectly. We were supposed to get negative 6 and 3. But of those two solutions, one of them isn't. Step number 4 is to check for extraneous solutions. Extraneous is spelled E-X-T-R-A-N-E-O-U-S. Basically, a solution is extraneous if it appears at the end, but it is not a solution to the original equation. One of these solutions isn't a solution. And it's not our fault that it snuck in. It just happened to, and there's a reason why. So you actually have to check each of these. Now, you can check them verbally, mentally, or you can write them down. Obviously, I'm going to write it down. Let's check the x equals 3. To check a solution to an equation, you go back to the original equation and replace each occurrence of the variable with what you claim is the solution. So on the left, I'll have the square root of 18 minus 3 times 3, and on the right, I'll have a 3. Now, if you ever see an equal sign with the question mark over it, it is asking the question, are these equal, as opposed to stating that they are equal. You may not see it in the book or in the homework, but I like to do that when I'm checking a solution. And when you check a solution, you can't do things like square both sides. Moves like squaring both sides or moving things from one side to the other only work on the assumption that things are equal. We're checking to see if they're equal, so we can't work under that assumption. Instead, what you do is you work each side individually. The right side is just 3. Well, what's the left side? Well, if we go inside the square root and multiply, 3 times 3 is 9, but we haven't subtracted or square rooted yet. And then subtract, 18 minus 9 is 9, haven't square rooted yet. Square root of 9 is 3. The last time I checked, 3 is equal to 3. This 3 is good. We'll put a box around it. But what about the negative 6? If I check the negative 6, I can do the same setup that I did for the 3. Go back to the original equation, rewrite both sides, except everywhere there's an x, put a negative 6. So we get 18 minus 3 times negative 6 on the left, and we get negative 6 on the right. Let's work the left side first this time. 18 stays put while we multiply. Negative 3 times negative 6 is positive 18. Now add the square root of 18 plus 18 is 36. And what's the square root of 36? 6. Now some of you may be trying to play devil's advocate right now and say, isn't it plus minus 6? Nope. Don't believe me? Get out your favorite calculator and ask it what the square root of 36 is. It will always tell you 6. But didn't we use plus minus? Yes, but, and this is a very important point to make. The time to use a plus minus is when you have an equation and then you walk up and square root both sides of it. Then you drop a plus minus. At no point in anywhere did we walk up to an equation and put a square root on both sides of it. So at no point does a plus minus come into play here. The square root of 36 is just 6. Which is a shame because the right side is negative 6. These are not equal, which means that x equals negative 6 is not a solution. So the only solution to this one is x equals 3. It wasn't our fault that the negative 6 snuck in. It's just the nature of this type of problem. In fact, here's why it snuck in. What was the very first move that we did? We squared both sides. You see this false equation? Well, currently it's true. Now it's false. This is a lie, right? 6 equal to negative 6? No, it's not. But what would happen if I squared both sides? Then it would become true. You would get 36 on both sides. Most of the time, when you do something to both sides of an equation, it preserves what's called the equation's truth value. If you add something to both sides of a true equation, it remains a true equation. If you multiply both sides of a false equation by a number, you get another false equation. There's one exception, but don't worry about it. But squaring is not one of those moves. Squaring can take something that's false and make it true. False, but when I square both sides, it's true. So the minute I squared this, it brought in the possibility of something that made the original equation false, but the squared equation true. You don't really have to worry about all that. You just have to remember, when you're solving a squared equation, your last move is to check for extraneous solutions. In the next video, we'll do one more problem and show you why there's a first move.